Hello everyone, welcome to my presentation. In the previous video, we learned how machine learning models are deployed into productions and how organization monitor those models after deployment. So today we are going to learn the final step that connects everything together. So our topic is machine learning operations are called MLOps and workflow automation fundamentals. So many people think that machine learning is only about building a model, but in a real company, there is much more work involved. Organizations need to manage many machine learning models, update them regularly, monitor their performance, and make sure everything continue working smoothly. So doing these manually would take a lot of time. That is why company use MLOps. So in this presentation, we will learn what MLOps is, why it is important, and how AWS helps automate machine learning workflows, how organizations manage the complete machine learning lifecycle more effectively. So let's get started. So before learning about MLOps, let's first understand the problem it solves. Imagine a small company that has only one machine learning models. Managing that single model is usually not very difficult. The team trained the model, test it, deploy it, and monitors it. Everything is manageable. Now imagine a large company like Amazon or Netflix. Instead of one model, they may have hundreds or even thousands of machine learning models. Some models recommend products, some detect fraud, others predict customer demand or help improve customer supports. Each model needs data preparation, tra- training, testing, deployment, monitoring, and regular updates. If engineering perform every one of these tasks manually, spend a lot of time repeating the same work. Manual work also increase the chance of mistakes. For example, someone might accidentally deploy the wrong model versions or forgot it to test and update model before releasing it. As organizations continue creating more machine learning models, they need a faster, more organized, and more reliable way to manage everything. This is the challenge that led to the development of machine learning operations or ML ops. So now let's move to the next slides. So now let's understand what ML ops actually means. ML ops stand for machine learning operations. It is set of practice that help organizations build, deploy, monitor and manage machine learning models using automation and well-organized workflow. Instead of treating every project differently, ML ops create one standard process that every teams can follow. This makes machine learning development more organized and much easier to manage. You can think of MLOps like a project manager. Imagine building a large house. There are electricians, plumbers, carpenters, painters, and many other workers. Without someone organizing everyone's work, the projects could become confusing and delayed. And a project manager keeps everything running in the correct order. MLOps work in a very similar way. It organizes the complete machine learning process, making sure each stage happen at the right time. Another important benefit of MLOps is automation. Instead of repeating the same manual task every time a model is updated, many of those tasks can happen automatically. This saves time, reduces mistakes, and allow team to focus on improving their machine learning model instead of repeating routine work. Let's move to the next slides. So now let's look at the complete machine learning lifecycle. You can think of this lifecycle as a continuous journey rather than a process that ends after deployment. The first step is data collection. Every machine learning projects begin by collecting information from different sources such as website, mobile apps, business database, or customer transactions. Next comes data preparation. The collecting data is cleaned, organized, and prepared so it can be used for training. After that, the model enters the training stage and where it learned pattern from the prepared data. Once training is complete, the model moves to evaluation. Here, engineer test the model to make sure its predictions are accurate before allowing real user to use it. If the model performs well, it's ready for deployment when it becomes available to website, application, and business systems. But remember what we learned in video 2. Deployment is not the end. Deployed model that must continue to be monitored so organization know whether it is still making accurate predictions. If monitoring so the performance is decreasing because customer behavior or business conditions have changed, engineer retain the model using new data. The updated model is then deployed again. The entire process continues throughout the life of the machine learning systems. This is why we call it a life cycle. Let's move next slides. So now let's learn about one of the AWS service that help automate this life cycle. So the service is called Amazon SageMaker pipeline. Imagine a production line in a factory. Each product move from one station to another. One station assemble the product, next station check quality, another station package it. Every step happen in the correct order. SageMaker pipeline work in a very similar way. Instead of manually starting every machine learning task, engineers create one automated pipeline. This pipeline connects important stages such as data preparation, model training, evaluation, approvals, deployment, and monitoring. Each stage starts only after the previous stage finishes successfully. If one stage finds a problem, the pipeline stops automatically. This prevents mistakes from moving into the next stage. For example, if the model does not achieve the required accuracy during evaluation, the pipeline can stop before deployment. This helps organizations avoid deploying models that are not ready for production. Because everything is automated, teams save time, improve consistency, and reduce the manual work. This is why Amazon SageMaker pipeline is considered one of the most important services for building modern machine learning workflow. Let's move to the next slides. So now that we understand how SageMaker pipeline automated the machine learning workflow, let's look at another AWS service that help manage trained model. The service is called Amazon SageMaker Model Registry. To understand why model registry is important, imagine you are working on a school project with your classmate. Every week, someone saves a new versions of the project. After a few weeks, you have file named Project Final New, Project Final Latest, and Project Final Final. After sometimes nobody know which file is what actually the correct one. The same problem can happen with the machine learning model. Engineer train many versions of the same model while trying to improve accuracy. Without proper organization, it becomes difficult to remember which model perform best or which version should be deployed. This is where Amazon SageMaker Model Registry helps. It stores all trained machine learning model in one central location. Each model has its own version number and information about how it performed during testing. Before a model is deployed, engineers can review its performance, compare it with previous versions, and decide whether it is ready for productions. In simple words, you can think of model registry as a digital library where every machine learning model is stored, organized, and easy to find whether it is needed. Let's move to the next slides. So now let's learn about continuous integration or simply CI. The name might sound technical, but the idea is actually very straightforward. Imagine you and your friends are building a mobile application together. Every day, different team members make change to the project. If everyone wait until the end of the month to combine their work, there is a high chance that many error will appear. Instead of imagine everyone uploads their changes every day, the system automatically checks whether everything still works correctly. This is exactly the continuous integration does, where whenever developer update machine learning code, training scripts, or workflow files, and the system automatically run tests. These tests states, sorry, these tests help identify mistakes early before they become bigger problem. For example, if someone accidentally changes a training scripts and cause an error, CI finds the issue immediately instead of allowing it to reach the deployment stage. Finding problem early save time, improve software quality, and help teams develop machine learning projects more confidently. So continuous integration is all about testing changes continuously instead of waiting until the project is almost finished. Let's move to the next slides. So after continuous integration finishes testing the project, the next step is continuous deployment, also called CD. Continuous deployment automatically moved an approved machine learning model into the production environment after it successfully passes all required tests. Let's use a simple example. Imagine a teacher checks the assignment before allowing you to submit the final version. If everything looks correct, you can submit it immediately. If mistakes are found, you must fix them first. Continuous deployment works in a similar way. The model is tested first. If it meets the required quality standard, AWS automatically deployed it. If problems are found, deployment stops until engineering engineer fix the issue. Some organizations also include an approval step. This allows experienced engineer or managers to review the model before it becomes available to customers. Instead of repeating the same deployment process every time, AWS handle many of these tasks automatically. So now let's connect everything we have learned so far. We have talked about pipeline, model registry, continuous integration, and continuous deployment. All of these technologies work together to support workflow automation. Workflow automation simply means allowing software to complete machine learning tasks automatically in the correct order instead of requiring engineers to perform every step manually. Imagine washing clothes. You could wash each pipe by hand, dry it separately, and iron every one at a time. Workflow automation work in a similar way. Instead of engineers manually preparing data, training models, testing results, deploying updates, and monitoring performance every time, the workflow performs many of these tasks automatically. This makes the deployment development process much faster and more consistent. As the organization builds more machine learning applications, workflow automation become one of the most important way to save time, improve productivity, and maintain reliable machine learning systems. Let's move to the next slide. So n- now that we understand how automation works, let's talk about another important part of MLOps, which is team collaboration. Many people think that building a machine learning system is the responsibility of only one person. In reality, successful machine learning projects involve different teams working together. Each team has a different responsibility, but all of them share the same goal of creating a reliable machine learning system. Like, let's look at these roles one by one. First, we have data scientists. Their main job to collect the data, prepare it, model machine learning models. They also test different algorithms and improve the model until it produces accurate predictions. Next are machine learning engineers. Once the model is ready, they prepare it for deployment. They automate workflows, manage cloud resources, and make sure the model can run efficiently in a production environment. Then we have a software developer. They connect the deployed model with a website, model application, or business software so the users can actually use the predictions. And finally, there are operations teams. They monitor the systems, maintain the cloud infrastructure, solve technical problems, and make sure the machine learning service continues running without interruption. Without good communication, these teams may work in different directions. MLOps help everyone work together using one organized workflow, making projects faster, more reliable, and much easier to manage. Let's move to the next slides. Let's see. Now let's understand how everything works together with a real example. Imagine a video streaming platform like Netflix. Every day, millions of people watch movies, TV shows, and documentaries. As customers continue watching different content, the company collect new information about their interest and viewing habit. Instead of asking engineer to manually report to the recommendation model every week, an automated MLOps pipeline perform most of the work. Pipeline first collect the latest viewing data, then it prepared the data and train a new version of the recommendation model. After training, the model is tested to make sure it performs better than the previous version. If the results are good, model is approved and automatically deployed. Customer immediately begin receiving improved movie and TV show recommendation without even noticing that the system has been updated. The deployed model continues to monitor the deployed model continues to be monitored. If customer interest change again in the future, the monitor systems detect the change and the pipeline automatically start another training cycles using the news data. This continuous process allows the company to improve recommendation while reducing manual work and providing better experience for its customers. Let's move to the next slide. So now let's discuss why organizations are investing so much time in MLOps. The first benefit is automation. Instead of repeating the same manual task, every time a model is updated, many activities happen automatically. The second benefit is better collaboration. Since every team follow the same workflow, communication become much easier. Another important advantage is faster deployment. Because testing, validation, and deployment are automated, organization can release improved machine learning models much more quickly. MLOps also help build reliable and scalable system. Finally, MLOps reduce maintenance effort. When machine learning projects are organized and automated, it becomes much easier to manage updates, monitor performance, and improve model as business needs continue changing. Let's move to the next slides. So before we finish, let's quickly review our complete learning journey. In video one, we learned how a trained machine learning model is deployed out into a production environment so that website applications are and users can request. Then we learned we deployed model must be continuously monitored to maintain predictions accuracy, detect a change in the data and ensure reliable performance. And in today's presentation, we learn how MLOps connect every stage of the machine learning lifecycle into one organized and automated workflow. So these allow organization to build machine learning system that continues improving over time while reducing manual work and increasing reliability. Together, these three presentations show the complete journey of machine learning model from training to deploy to monitor and finally to fully automation. So thank you. This brings us to the end of my presentation on machine learning operations, MLOps, and workflow automation fundamentals. So today we learn how organization automate the complete machine learning lifecycle using MLOps principles and AWS service such as AWS SageMaker pipeline and AWS SageMaker model registries. I hope this presentation helped explain MLOps in a similar and practical way while showing how deployment, monitoring, and automation work together to create successful machine learning solutions. So thank you very much for taking the time to watch my presentation. I would also like to sincerely thank you to my professor, Dr. Bhakti Swami, for this continuous guidance and encouragement and support throughout my learning journey. His practical technique style and real-world approach to cloud computing and machine learning have helped me understand this concept much more clearly. I truly appreciate his mentorship and opportunity he provides for students to continuous learning and developing their technical skills. So thank you once again for watching this presentation and have a wonderful day.